Good morning, class, and welcome to week 4 of eSchool. I wanted to make this video as an introduction to our 2 modules for this week, as well as a space for me to make a couple of announcements and give you an introduction to what we're going to be learning this week. Let's start with Module 1. Module 1 and Module 2 of this week deal with building our initial model of sound. From now until the end of this eSchool environment, we're going to be working with waves. Waves is our last peer unit. That's why we're going to be seeing this W.1 next to these. We're going to study the properties of waves, how they propagate through matter, how they are received and sent. And we're going to, really importantly, we're going to begin to build our model for how sound travels through a medium. Now you have 2 modules for this week, week 4 module 1 and week 4 module 2, which we'll discuss in a moment. In each of your modules, you have 2 documents. You have Hensley week 1 digital worksheet, and then you have an adjusted modified worksheet, It is your discretion on which one of these you feel like would honor you the most and push you the most. The Hensley week 4 digital worksheet, the non-modified one, is more rigorous, The Hensley modified worksheet, it has some sentence stems, some helpful hints, and anything like that in case you wanted to use them. You can turn in either one, and I will count that as full credit. Now remember, guys, participation in this class is worth 80% of your grade. So turning in these documents, just turning something in, is 80% of your grade. The other 20% comes from whether or not you did the formatives. So let's go ahead and click on the Hensley week 1 digital worksheet. As in the past, you should open up a copy of it. Each of you received a copy of both worksheets, so you are able to edit them immediately. The objectives for this module are: 1, students will be able to create a model for sound that accounts for observations you see during your experiments. 2, students will be able to understand how sound moves from a source to a receiver. I'm going to use the word propagation a lot here, guys. If I ever say propagation, I mean a movement of a wave through a medium, or like air or water or anything like that, Kind of the agenda and your timing for this one is you should spend about 10 minutes on the do now, 5 minutes watching the direct instruction video, 20 minutes working through experiment 1, 10 minutes from experiment 2, and 5 minutes working through your mastery check at the end, Once again, this mastery check here, guys, is linked into Edulastic. The title of it is at the bottom of this worksheet. I will outline it here. This is the title of the formative, and you can put that into Edulastic and take that formative, Make sure you guys pay close attention to those mastery checks and formatives, Even though they're not worth all the 80%, they are still really important, and it helps us see where you guys are mastering this stuff and where we need to focus more on, Starting with the do now, you've got a couple questions to answer, Anything that's highlighted is a sentence stem. You type in after that. If you need text to speech, you can click on this button here, and that will read the question to you along with any other information. Question 1 says, watch this video. So you're going to click on this video right here, guys, this link here. It'll take you to a YouTube video. This video describes a candle flame and a speaker. Hypothesize, why do you think the candle moves back and forth without anything visible hitting it? Describe your reasoning. You may find it helpful to draw a picture. So feel free to draw a picture, guys, remembering that to draw a picture, you go up to Insert, Drawing, New, Then you have options here about what you want to do, whether or not you want to actions, you want to scribble, whether or not you want to draw objects, text box, insert an image, anything you guys think is important there, We're going to go ahead and save this and close it, and when you save and close it, that document or that image will be posted here, This one says, you may have heard sound is a wave, and you may have seen pictures like the one to the right. Describe what you think this wave represents. In other words, what is this sound wave? So guys, remember, these are just your initial ideas. There's no wrong answers here, We don't have an answer key here because we're not going to penalize you guys for doing anything wrong here. This is what we want to see what you guys are thinking at this point. Before moving on to your experiment, we really want you guys to focus on watching this direct instruction video, It's going to kind of walk you through what you're going to do during these experiments, as well as provide any essential information for your success in finishing the module. After that, the big chunk of your time is going to be spent on experiment 1. What model for sound can account for your observations? Guys, really important that you follow these steps in sequential order, okay? Watch this video of a bell inside a jar. Make observations of what you hear when the air is removed from the jar. So guys, that's what we call a vacuum. Remember we talked about that with Newton's second law, all right? And the fact that all objects in a vacuum fall. There's no air in a vacuum. It's all sucked out. So how does that affect the sound propagation in a vacuum, okay? Make sure you watch this video. After that, you're going to make a claim, all right? An example of a claim could be, all right, I don't think sound can travel in a vacuum, or I do think sound can travel in a vacuum. Okay, evidence for that would be, look at this video and quote the video in your evidence. Say, according to this video, it is clear that sound cannot travel in a vacuum. All right, moving on to step 2, it asks you to draw an initial model for how sound moves from a speaker to an ear. So here, guys, remember to edit a picture, you right-click, all right, you select it, click Edit, and now you're once again in this drawing atmosphere, and you guys can scribble on this, okay? If you want to scribble, you go to Select Line, down here to Scribble, and you guys can draw whatever you want, okay? All right, when you close that, go ahead and erase that. When you close that, it's going to be posted here with the adjustments you made. You're then going to think back to the candle flame that you talked about in the beginning ideas. How has it changed? Okay, have you learned anything new? Is there anything you want to add to your initial ideas? Okay, bell jar video once again is linked here. Make sure you guys read this key idea. All right. All right. We were going to be using a slinky as an analogy for how sound travels from place to place. Analogies can be useful tools, but as far as any analogy or model, it is important to remember that there are limitations. Guys, recall that a model is a way that we study something we can't see. Okay, like with this candle flame, we can't see that flame move. We can't see the propagation of the wave, but we know that it's there because we can see the movement. So we make a model for that thing that we can't see. Okay? Step 3, make sure you watch this video and answer the questions over here where you ask to define disturbance in your own words, as well as answer this question about the slinky coil with the ribbon. Okay? 4, fill in the blanks to the right. These statements are important claims that wrap up the main ideas for this experiment. Okay? So make sure you fill in these ideas with what you've learned so far. Alright? You can check out this visualization down here about how a sound wave really works. All right, notice how there are something we call wave fronts moving through here. Okay, really important that you guys pay attention to this, really internalize it. This little animation will be really important moving forward. Okay, describe the motion of the red particle. Go ahead and answer this question, guys. You're then going to walk through this claim, evidence, and reasoning portion where you talk about make a claim, provide evidence from the experiment we just finished, as well as reasoning that backs that claim, as well as the evidence up. Okay? If you want sentence stems, go ahead and click here, and they will input some sentence stems for you. So that's a great way, if you're stuck, to get a couple hints. Guys, when you're done with that, make sure you check your answers. When you click this, it's going to open up a new Google document that has the answers you are looking for in it. Okay? Going back to this week 4, module 1, you are then going to spend 10 minutes working on experiment 2 about how does sound move from a source to the receiver. All right? You're going to go through the problems the same way we did before, making sure that anything highlighted in blue or underlined in blue is watched or clicked on so you have all the information before you guys get into this topic, okay? After this experiment, which is much shorter, make sure you check your answers, read through the key points in the lesson. There are 5 of them, okay? Make sure you read all 5 key points before starting this week's mastery check, which is titled DL_mastery check Pure Physics Week 4 Module 1. Okay, that will be once again linked in Edulastic. Alright guys, so this is basically all you guys have to do for Module 1 here, okay? Now, because we only have 2 modules this week, I'm expecting Module 1 to be due on Wednesday and Module 2 to be done by Monday, okay? If you guys have not completed Module 1 by the end of Wednesday and into Thursday, I'm going to be sending out an email to your advisors to say who hasn't and who has completed it. If you like to work on it, I know some of you guys like to work on these later in the week, just send me a Teams and say, hey, I like to work on this later in the week, but I'll get it done. If you at this point have a good record of getting your work done, I'm definitely going to be able to trust that, and I'll be keeping that in mind moving forward. All right, guys, this is our video for week 1 model for sound, week 4 module 1. Okay, let's move on to week 4 module 2. All right, so we'll go back to our original page and see that that's linked here. I'm going to go through this a little bit quicker so that you guys have enough time, and we've already gone through the basics of it, so I really want to make sure that we can get moving forward and you guys have a good idea where you're going to be. Okay, quick note here. All right, we have some vocab in this one, so we'll make sure to go through those in a moment. Our objective for this second module is students will be able to understand a model that explains how sound moves from a sound source to a listener. Agenda. You're going to spend 5 minutes on the do now, 10 minutes read to learn, 15 minutes partner practice, 10 minutes independent practice, and 15 minutes formative assessment. Okay? Vocab words you're going to learn here. All right, you're going to talk about disturbance, a high-density region of air particles that moves through a medium. Medium, guys, is anything like air, water, anything that things can move through. All right, plasma, lava, anything like that. Longitudinal wave is a wave in which the particles vibrate parallel to the direction of the disturbance travels, are called longitudinal waves. All right. Scientists refer to the type of material in which particles vibrate as the material medium, like I discussed before, solid, liquid, gas, air, water, anything like that, okay? Density diagram, the picture to the right here, all right, guys, represents the model for how sound moves from place to place because this picture specifically shows the movement of particles. We can refer to it as a density diagram. So that, guys, you're going to spend 5 minutes doing this quick do now. All right, making sure you check your answers using this link afterward. All right, after this, guys, you're going to read the scientist's ideas reading below, pull out the new vocabulary terms, and define them here. Okay, so the vocab terms here, definition here, along with an image over here. Okay, use this checklist here to make sure you didn't forget any vocab terms. Okay, the checklist over here, once it loads, make sure you've defined disturbance, material medium, longitudinal wave, and density diagram. All right, guys? All right, let's move back to this. After that, guys, you're going to have a quick partner practice. In this idea, you're going to summarize the key ideas from this activity in your own words. Okay? 2, find your partner, all right, which we will upload your partner there. Share your summarized key ideas with your partner, give each other feedback, and make revisions to your own work based on feedback. All right? This is a really good way for us to make sure that we're moving more towards a synchronous learning environment than an asynchronous learning environment. So it's going to give you guys an opportunity to work together a little bit. All right? Each key idea is listed out here. All right? And it comes straight from this scientist's ideas reading, which I will go through on Wednesday during our class period, okay? These are the scientist's ideas, should look very familiar to you, all right? So it should be a familiar environment for you to work in. Okay, from here on, guys, you have an independent practice section where you're going to answer these questions independently, all right? Make sure you're using those scientist's ideas reading to do this, guys. All the answers to these are in the scientist's ideas reading, okay? Make sure you've checked your answers and checked your key ideas before moving on to DL_Pure Physics G.5 formative. All right, crew? So, going back to this, okay, big important idea from this module here is this partner practice. It's something new that we're trying, okay? I'm going to upload this list here, so you're going to be able to find your partner in that list and work with your partner to complete this 15-minute assignment. Okay? Crew, it's really important that for this second module that you guys are all logged on to that meeting so that you guys can work through this as partners, okay? Basically, get this, crew, this is it. This is all due on Monday at noon, okay? Remember, we have no school Friday, so make sure you spend that time enjoying it with family, relaxing, debriefing from this week of e-school, all right? Quick recap of what we've learned so far. Pure physics, okay? We've got 2 modules for this week, Module 1 and Module 2. Remember, we start with Module 1, working our way through that document, step by step, following along with the instructions, and making sure we've clicked on every video. If you guys run into any technical issues, please don't hesitate to reach out. Thank you guys for listening, and I will see you soon.